All right, we're back for round 3 here. So in front of me, you'll see the unit circle, and I went ahead and just filled in all the multiples of 45 we talked about in the last one. So they're 45, 135, 225, and 315. And I also went in and filled in the angle measures for the multiples of 30, because that's the next kind of missing piece that we're going to fill in here. So we've got 30, 60, 120, 150, 210, 240, 300, 330, etc. You'll notice here, I'm going to fill in this one, 360 degrees, it's the same thing. You'll notice there's an extra blank line. We're not going to worry about that for quite a while, so just don't pretend it's not there for now, it's fine. The next thing we want to do is fill in the rest of these a little bit, and that whole process is going to kind of come from the same place. We already looked at 45, 45, 90 triangles. This one is going to be a 30, 60, 90 triangle. So we're going to start there and see if we can't figure out a way to kind of fill in the blanks a little bit. So I've got a 30, 60, 90 triangle. This is 30. That's 60. And here's my 90. And we know that since this thing is on our unit circle, 1 unit, our radius is 1, which means that this distance here, or the hypotenuse here, is 1. And the trick for finding out some of the other lengths here involves filling in what's called an auxiliary line. It's kind of a rabbit out of a hat. But if I take this and I kind of clone that triangle and I create a duplicate copy over here, with that being 30 and this being 60, all of a sudden I've created an equilateral triangle. And that lends some implications and some new info to the scenario. So that's 1. That means that this is 1. It's equilateral, so this is also 1. Well, given that this is directly through the midpoint, that means this is 1/2. And all that's left now is to use some Pythagorean theorem to figure out this bottom line. So I'm going to do that over here. We've got 1/2 squared plus our x value squared equals 1 squared, or 1. 1/2 squared is 1/4. So I'm going to do 1 minus 1/4. 1 minus 1/4 is 3/4. Taking a square root, we get that x is equal to the square root of 3/4, which is the square root of 3 divided by the square root of 4, which is 2. So with that in hand, I now have the ability to fill in a fair amount more of this unit circle. This base is root 3 over 2, and that corresponds to the x value of this first point. So I'm going to go ahead and fill in root 3 divided by 2. And we know from here that the height is 1/2. So I can fill that in. And that seems like all well and good, but what the hell else about the rest of the stuff here? But it ends up that this is really just kind of symmetry. If this is a 30, 60, 90 here, well, this is a 60, 30, 90, right? Because our 60-degree angle is just here, and our 30 would be up here if we drew this triangle down. And all that means that these two coordinates are going to reverse. The x is 1/2, and the y is root 3 over 2. And then we can take that, we can clone it over here, and we get negative 1/2, and root 3 over 2. And we get negative root 3 over 2 and positive 1/2. We drop it down and we get negative root 3 over 2, negative 1/2. And we get, negative 1/2 here, negative root 3 over 2. Oh, that was already there, I guess. And then 1/2, negative root 3 over 2, and root 3 over 2, negative 1/2. So at that point, we're able to actually kind of fill in pretty much the entire unit circle. And I'm going to post in Classroom a filled out and completed version of this unit circle, so it's a little bit easier to read. But that's where this comes from. And it allows us to then do some problems, like, for example, this particular beastie right here, where it says 5. Use the unit circle to find the values of the 6 trig functions for 120 degrees. So I'm going to pull up my unit circle. I'm going to find 120 degrees. That's here. And from earlier, we know that every point on here is the cosine of the angle, comma, the sine of the angle. So that means that if I'm looking at my 120 here, I'm just going to fold this page over to see what the hell we're looking at a little bit easier. If I'm looking at my 120 problem, well, the sine is going to be square root of 3 over 2. So we'll say sine root 3 over 2. The cosine is going to be negative 1/2. The tangent is going to be sine divided by cosine. So this divided by that. When I divide, I flip and multiply, and that's going to come in pretty clutch here. So instead of dividing by half, multiply by negative 2 over 1. And that plays really nicely. Times negative 2 over 1. The 2's cancel. The 1's doesn't matter. It's just negative root 3, right? Sweet. Golden. And then for the other 3, sine is the reciprocal of cosecant, and cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. So, cosecant, flip it upside down. 2 over root 3, and negative 2 over 1. Negative 2. And this one, what do we got here? So 1 over, negative 1 over the square root of 3. It is bad form to have square roots on the bottom, so we rationalize. We multiply the top and the bottom by the square root of 3. We get 3 here canceling, and we get 2 root 3 on the top. 2 root 3 over 3. This one's good. This one, multiply the square root of 3 on top and bottom. So then we have square root of 3 with a negative sign over 3. Okay. That's all there is to that, and it's a little bit of wordplay and Rubik's cubing, but it's nothing crazy. These ones aren't really unit circle problems. I do want to mention it. I don't really like the way that they word this. It's confusing with the standard position and the given coordinates and all this garbage. All it really means is to plot that point and kind of think about how would that triangle be oriented. So I'm going to do this one, for example. Negative 1, 5, and I did a pretty crap job here of laying the damn thing out, but you know, we're gonna freaking go with it. It's fine. Okay. So we're going to pretend this is the negative 1, and that's our 0, 0. I know the dimensions are weird, but whatever. Negative 1, 5. All it's doing is telling you that the point negative 1, 5 is up here. That's it. You don't need to worry about terminal position and angles bigger than whatever. I don't care about this. Doesn't matter. I know standard position is off the x-axis and we're supposed to be going like around. It doesn't matter. We can use the reference angle and just build ourselves a handy little right triangle, rock and roll. It seems weird because there's a negative there, but it doesn't actually matter. So we run our Pythagorean theorem. Negative 1 squared is 1. 5 squared is 26 or 25, right? 25. And then this is going to be my h squared. So h is going to be the square root of 26. Cool. Once we've got that figured out, this is the exact same as any other trig problem you've done. You get your angle, you got your opposite, you got your adjacent, you got your hypotenuse, rock and roll, build all your little fractions out, rationalize the denominator. If the square root ends up on bottom, it will probably do that for sine and cosine, and maybe some of the reciprocal, and that's fine. But that's how that plays out. There just really isn't that much to it. This is a lot of confusing wordplay. It's not the end of the world. You know, for 8, you're going to lay it out as negative 3, negative 4. You build it up to the x-axis. Here's your little triangle. Rock and roll. Cool. Thanks, ladies and gentlemen. We'll take a look at 5-4 before too long, but for now, see ya.